All right. So today is about cheaper testing. Yesterday I talked about how to do testing in the first place, and if you've actually tried to do this in practice, you'll notice that there are a lot of pain points involved and a lot of typing that you really shouldn't have to do, and some issues with specific situations as well. So today I'd like to elaborate on the work that's been done to make testing even cheaper, so that you should have to write less and maintain less, do less in general to get it to work. I have to steal a bit of content from an earlier presentation I've done at Google last year. I'll only go over some of the theoretical details that we haven't looked at yet, and then I'll look into a specific practical situation of how you would apply this in practice, where you can follow along if you'd like. All right. So let's say you've just written some new code, and you notice that you'd like to use an integer, and you expect this integer to always be prime. You think, oh, well, it's not just an integer, it's actually a prime, so I'll wrap it in a new type. But now this new type has an invariant. You need to make sure that the integer is always prime. So that means it's positive, and then all the other conditions on it being prime. So now you have a new type here. We call it prime. It has an integer inside, and it needs to be prime. When you enter, could you please close the door so that people who are making noise outside? Thank you. Now, we'd like to be able to talk about what it means for a value of this type to be valid. So there is this type class called validity, which allows you to specify what it means for a value of this type to be valid. Exactly what it means. So now this is not just documentation anymore. You can actually check whether such a thing is valid. And the semantics of this validity type class mean that there should never, ever, ever exist a value that is invalid. If it does, the programmer made a mistake. It could be that in the flow of your application, the user could do something wrong, but it's still a valid thing for them to do something wrong, and you want to model that. That's not what validity is for. This is really for if any value is invalid, then you made a mistake. And it should be an under approximation as well, so it should say this thing is not valid even if it is, if that's necessary, but it should never say that something is valid if it isn't. And then you can have some validity for, there are some standard instances like validity for lists, so that anything in a list is valid if any element, if all the elements inside our list, etc., are valid, etc. Now, if you derive generic for your data type, then the entire validity instance can be generated for you. So you need this deriving generic thing. You'll need a type, no, not a type extension, a language extension called derive generic. And then you'll be able to write instance validity of my type, and you won't have to write any boilerplate. This was the original implementation of validity, and then this is a problem. Now you can say, well, prime 6 is not a valid prime, of course. But let's say I have this list of primes. If you ask if it's valid, it will just say, no, it's not valid. And then you can start looking into where the problem is. Now, I've worked on an application where I had a large data type with a lot of constraints. I had a test that checked if something was valid, and I had 3 pages of output saying this is not valid. And then I'd have to start looking where the problem was. So the new implementation of this type class contains a function called validate, which checks why something is invalid or valid. So then you can specify, then you get an output like this that says the element at index 3 in the list, that's this one, there is a violation of an invariant, it's not prime. And then you know exactly where the problem is. So this in and of itself could be quite useful for testing. But this concept happens to allow for cheap testing in the future with what I'm going to show you next. So we talked yesterday about the generators in QuickCheck called arbitrary, where you specify an arbitrary instance. Oh, I'll have to get back to that in a moment. First, I have to make a detour what a test is. Quick rundown. A test is a piece of code that you run. If it crashes, then it fails. If it runs and it doesn't crash, then the test doesn't fail. This is the most general way to describe a test. And then things like should be are just an easy way to make things crash. A property test is a test that takes an argument. A randomized property test is a test that takes an argument and you supply random arguments. An exhaustive property test is a test that takes an argument and you supply all the possible arguments. And then you have a specialized exhaustive property test, which is a test that takes an argument where you hand in all of the arguments of a subset of the possible arguments. And then there's a specialized random property test, and this is the thing I'll be talking about, which is a test that takes an argument where you supply random elements that are in a subset of all possible values. And the subset here will be the valid values. Because usually you don't care if your code works for prime 6. You're going to assume that you haven't made a mistake, or you test that you haven't made a mistake, so that your code doesn't have to work if the prime that you supply is 6. Well, the not prime that you supply is the 6. So this is what we'll be talking about. A specialized random property test is a test that takes an argument where the arguments that you supply are from a subset of all the valid values. So in QuickCheck, you have this arbitrary type class, which has an arbitrary generator, and then you can run a test with arbitrary values. But if your data types have invariance, then you don't really know what you should put in this arbitrary type class. And as a little detour, there are two kinds of constraints on a value. The ones we can model as a type, and the ones we can't model as a type. Using this type class, you've now had all of the possible invariants that you may want to specify, excluding undecidable invariants, but that's a very minor problem. So what do we want to generate in this arbitrary type class? You can either generate only valid values, but then you can never test that your code still works if you supply invalid values, if that's something you may want, for example, for validation. Do you generate truly arbitrary values, but then you can never test your code that is only supposed to work with valid values? Or do you have separate generators for each? You can't do that either, because now you have to maintain two of them, and they no longer compose, and they no longer allow for these nice property combinators. So the problem here is that arbitrary really has no semantics to talk about how you should implement it. And that's where the next solution comes in. We made these other two type classes. One is called gen unchecked, which has the semantics of generating truly arbitrary values. So any possible representable thing at runtime needs to be able to be generated by this type class. That's the semantics. Because it has this very clear semantics, we've implemented it such that you can just instantiate gen unchecked, and the compiler will figure out the implementation before itself, if you have derived generic. And then there's a separate one called gen valid, which has the semantics of only generating valid values. And gen valid has a default implementation, which says that generate something unchecked, check it. If it's valid, then return it, otherwise don't. So this has a default implementation, which means you don't have to do any boilerplate here either. But if this is too slow for you, and it very well could be, then you can implement it yourself and make something that's probably faster. Everyone still with me? Is it clear where this is necessary? All right. Now you can write very general properties about tests, about your property combinators about your code. For example, this first combinator says that this function that returns a maybe, so it can fail, it will fail if you supply an invalid value. This is the kind of test you always want for smart constructors. Valid if succeeds checks that if this function doesn't fail, then the result will be a valid value. This is also something you want for your smart constructors. Succeeds on valid says that if you supply a valid argument, then it will always return a just. So these are very general combinators that you can write that are very widely applicable, so that you don't have to rewrite this test every time. The idea here is that it should be very little typing to make sure that your tests reflect what you want your code to do, and we actually go much farther in that as well. Then there are some generalized properties that we can now express using this gen valid concept. These exist for QuickCheck as well, but they break down if you have invariance, and they no longer break down now. For example, equivalent on valid says that two functions give the same output for the same input as long as the input was valid. And then associative on valid says that this binary operator will be associative as long as the inputs are valid. This is something you may want to apply to doubles that doesn't hold for arbitrary doubles, per se. This one says inverse functions if succeed. This is quite complicated, but these are two functions that can fail in different ways, possibly in different ways. So they could return a maybe and an either, for example. And these functions are inverse functions of each other as long as they both succeed. That's what you're testing here. So there's an entire library of about 500 of these that have already been written, so you can just use them in your test suite.
What's an example of inverse succeed?
Serialization. Mm-hmm. So this is nice for round-trip testing. I'll talk about round-trip testing later, but in general, you need to have both kinds of round trip. So from A to B and back is different from B to A and back. So watch out for that. That's why they can both fail. But there is also a separate function where one of them can fail and the other can't, or the other way around, etc. And now that we have these property combinators, you can do the same thing for the test suite combinators. So here we have ORDspec, which will test all of the properties that you expect from an ordering instance. And now you can also do this such that it only needs to hold for valid values. And then you get nice output like this. So in the presentation yesterday, I showed you the similar thing for the equality instance, and I left out most of the output that you're not interested in. But here you can actually see that it prints, including the errors that have been fixed by now, why or for which kinds of ints the properties hold. You can also do this for non-simple kind of types. So these functions all exist. You don't have to write them yourself anymore. They're in the library. You can just use them. In this case, the functor spec will check that the functor laws hold for a given functor. As long as, and this is the important part, you can check equality of ints in the functor, and you can generate ints in a functor. So for lists, for example, you can check this. For I/O, you can't, because you cannot compare I/O actions at the moment. So then you get nice output like this. And this is the part that you put in your test suite. So it's really not a lot of typing. And that was the goal here. And you can do the same for applicative, for monad, monoid, et cetera, et cetera. They all exist. And then you can have specialized ones in for separate libraries like asyn. So this test suite combinator will check that the JSON instances make sense. So it will check the round trip properties. It will check that if you encode something, it will never explode in your face. If you decode something, it will fail instead of throwing exceptions, that kind of stuff. So you just put in the single line, and then you're covered as far as JSON goes. And then you get output like this. So you have inverses of encode and decode, and it never fails to encode something. Now, here is what it will cost to use something like this. You need derive generic, which is a line. You need gen unchecked of my type, validity, and gen valid. So a total of 4 lines to enable this concept. And they're all generated for you. The instances are all entirely generated. And then you can start using these libraries. Now, this is the presentation I had, but let's do this in practice as well, given that this is a summer school and we have some time for it. But I'll need to open another one of these projects and turn my table around, so you'll have about 3 minutes of a break. How much time do I have?
Yeah, all here, please.
Right. All right, cool. Oh, you could have asked me that before.
I think there's even a button for that.
Oh, there is?
The bottom one. Way better. Oh, it's not working. Harden is broken, maybe it's broken.
All right.
Or maybe it's not broken.
Yeah.
Let's experiment with it. Whoa, that's nice. It doesn't say closed.
Maybe you have to stand or press the button.
I don't think I want to do that. Will it stick? I suppose.
Right. Let's see if you can follow along. So I'm going to show you how this validity thing works. So if you want to follow along, now is the time to start. I just did stack new code to make a new little project. And we'll need some things. So I'm going to add the validity thing at the moment. The right version isn't in Stackage, I think, so I'll have to. Let me just check that that's true. LTS 11.13. Validity. Yeah, the newest version isn't on Stackage yet. So you'll have to get it from the right version from here. So we do git commit shifters No, you can copy paste it in the same way I did. From the link I put here.
I'll paste that on the report.
Perfect.
Development branch?
Yep.
Screen is dry.
So now I need to somehow
all the subdirectories in that repository, you want those in, yeah,
Yep, and now I can start using them. So, oh, that's actually a great idea.
Yeah, that's just the comment it's telling me.
How do I do that?
You have the binary, the executable. Yes, the executable.
Oh, no, I don't.
Just that github.com. Paste it.
I always forget how Xcloud works.
Can you pipe it to the export?
including the zip drive
Where did you want me to post the GIST link?
Do you have the Discord?
Discord. I probably do, but
There's a channel. Beginner's track.
I see.
Wow.
Looks like the creating the gist part didn't work very well. Oh, there it is.
You can also paste it in Bitly, so people run it.
There we go. A gist. So this shouldn't be necessary in about a week, but at the moment it's still necessary. And now I can start adding this in the package YAML. Let's just start with validity. So the idea is that you never add gen validity or gen validity whatever else in your library dependencies. You should only add validity packages in your library dependencies. So all right, can everyone follow until here?
The only validity, were there any changes in package.yaml? Only validity?
At the moment, yes. But I'll use the rest in a moment, so that's why I put them in the stack YAML already. All right, so I'm also using hspec again, which is the same thing from yesterday, so I have to copy paste the spec file again. So in the test dependencies, I also add hspec and quick check so that we can talk about generators and tests. All right, so now I'll have to reuse another one of my interview questions. But
Can you open up your spec.hs first?
yes,
I have a feeling you're going a bit too fast.
good feedback.
How about just putting
That's the one you copied from the website. So don't have to rewrite it.
Alright.
The website of
But like in general, it's just, I hear a lot of people like, oh, hey, where do I get this?
Yeah,
There's still
and,
people fetching the stack.yaml thing, so.
Okay.
Why don't you just put a, like,
Push it to a
commit
repo
that,
maybe,
put that to
so
a
we
repo,
can
people
just
clone
clone it.
And then there's no guesswork involved, you know.
All right.
That's a good idea.
Well, the thing is, I was trying to make sure that everyone knows the steps to follow from scratch, so that you know what to do if you get your errors yourself. But I can make a quick repo.
We can then look at the diff and make sure we did everything right.
Yep.
So what's the step after we get the YAML file sorted?
Yeah, so you,
why should we put validity? I don't know.
Whoops, that's wrong. All right, I made a quick Git repo for everyone to clone. It's in the beginner's track on Discord as well. So let me just walk over what I just did. I made a new project. I added the location for Stack to get the validity dependencies because at the moment they're not on Stackage yet. Then I added validity to the build depends of the library of the package that we're just making now, and I added hspec and quickcheck in the test dependencies. That's all for now.
White has to be dependency of library.
Sorry?
White has to be dependency of library.
Oh, so validity is about the validity of your data types.
Right.
This is
It's not really test kind of thing.
it's not testing per se, and in fact I use it in the library usually as well.
Alright.
There are some helper functions that we'll be able to use. All right. Everyone found it?
Yeah.
Okay.
So you probably use the routines that you make for validation in the actual library. That's what.
Yeah.
Got it.
All right. Now I'm going to steal some material from my own interview question that I've used in the past a lot, so I'll have to come up with more questions. I've run into a problem at some point when I wanted in a web interface to display a nice string that represented a relative time difference. So I wanted to be able to say this file was uploaded at date X, and you can add the UTC time so you know exactly when that was, and then it says 2015-06 whatever. But you need to, I was more interested in when that was related to now as opposed to the actual date. So I wanted to say something like 2 years ago as opposed to the exact date. So this is the use case. Now, you can try to get the nominal diff time, which is a time between two UTC times that doesn't say anything else than how many seconds it was, and then convert that into a string that is nicely represents when, how long ago something was. But then if I ever wanted to change the way that the time was represented, I would have to rewrite this entire thing. So I'd prefer to actually have an intermediate data type that represents how many hours it was, how many seconds it was, how many days it was, and whatever, and then have a separate function that renders this to a nice string for the user. Does it make sense, what I'm trying to do here? When I made this, it turned out to be very complicated to get it right. And this was a very nice example of where validity could come in handy. So let's see how we can get started with that. So I want a data type to represent, let's talk about time differences within a day, right? So only hours and minutes, for example. And you'll note that I'll have to change the way my data type works based on how I will test it. This is usually the case. You'll have to change the way your code works based on how you want to test it. And you'll see immediately when that happens. So let's start with just a data type that has a representation of how many minutes and how many hours a certain nominal diff time was ago. So I call it hour minute. Is there a way to put this down so that you can actually hear me through the mic? Can you hear me better now? All right, so we have one of these data types. Everything still compiles. And now we'd like to be able to say import data dot time, and then hour minute, which should be a function from nominal diff time to hour minute. And then it will complain about dependencies, so you'll have to add that to the package YAML file right there. And for good measure, you'll also need validity time in a moment. Then I made a little test file to start testing this, and there you'll need to import test.hspec in and test.quickcheck for in a moment. All right, is it clear what I tried to do here? So if you look at the documentation of nominal diff time, it's actually just an integer number of picoseconds. So we'll want to transform this integer number of picoseconds to this hour-minute data type. The first thing you should notice, actually, what is the first thing you notice when you try to convert picoseconds into this hour-minute thing? Sorry? Yes, you lose some information, right? Because you cannot represent picoseconds anymore. We'll get into trouble with that in a moment. But if you hadn't noticed that, the test that we're about to write will tell you this. So let's start with getting the basics out of the way. Can I do that? Now, let's say I want to define to be able to talk about this hour minutes thing. Then I write instance validity hour minute, and I fix all the compile errors I get. So you need import data.validity, and then it will complain that this is not generic enough. Right there. So you have to also derive generic. Which means you need to import generic. And you need to add this language extension that says you're allowed to derive that. And then it should compile. What did I do wrong? Oh, right, language. And then it should compile. Now we can talk about validity of this thing. Can everyone follow? Is it too fast still?
How do you run a test?
A stack test.
And it just keeps on going?
No, then you need stack test file watch. Okay. So stack test -- file watch. This is a general recommendation for any time you're trying to write some code. Make sure you have a feedback loop set up that you don't have to press buttons for. All right, so on the top left, I can maybe show you. This is the command I wrote, so that's stack test file watch. This will just run the test suite, and whenever something changes, run the test suite again, so you can have some iterative programming. So now we can talk about validity of our data type. At the moment, the validity instance is such that it will say that any value is valid. But that's not entirely right, is it? Because hours cannot be negative, for example, or can they? That's the thing. Now you need to start thinking about that. But before we start thinking about that, let's look into what kind of tests you would want to write to check if hour minute is has a valid implementation. So whenever we see that something is wrong, write a test first that shows you that it's wrong, so that you can never pretend that there is no problem, and then you can start fixing it. So at the moment, there is a very obvious mistake here. Well, not a mistake, just something that hasn't been done yet. This undefined here should get us into trouble, but running the test suite doesn't get us into trouble. So let's start some trouble. The standard thing I always want to write for this kind of test is called produces valids on valid. If you put a nominal diff time in that is valid, then you should get a valid hour minute out. All right, so let's do exactly that. And you'll have to fix a bunch of compile errors. So you'll import test.validity. This will complain. Voila, because you need to add gen validity hspec. And we need to import lib as well. Right. So we have to start fixing all the compile errors. Luckily, the compiler shows you exactly what's wrong. I missed the show instance. I also missed an equality instance. And now it says I cannot generate these. But we actually have generators for it, and they're in gen validity time. So you have to import data.genvalidity.time. There is nothing in there except instances, so you add this unit thing at the end. And gen validity, oops, is with a capital V. There we go, and now we have a test suite failure because this thing is undefined. Can I show you that a bit better? There we go. Everyone still with me until here? Anything missing?
I'm having an error running the repo.
Running the what?
But I could not read from the remote repo.
Oh, this is a Git link.
Okay.
So if you want to be able to clone it without any SSH keys, you need to use HTTPS, I think.
Okay.
If you haven't set up the Git integration for your, the SSH integration for your Git locally, you may have to use an HTTPS link instead of the Git link.
Sorry.
Yes?
No problem.
I cloned your repo,
Mhm.
right? And then try and push that here.
It's exact. Oh, you managed to clone it?
Yeah, but using HTTPS. And now it's saying something about access rights for something else.
Oh, right. So in the stack YAML that I provided, I may have given you the wrong link to the dependency. Because in here, if you haven't set this up right, you may have to use an HTTPS link instead of the Git link. So if you use this instead, that should work better. Right, I just cloned everything we had until here, so you can see if you can, sorry, I just pushed it, so if you can see if you can clone it again and check if it works now. Any more problems? Show error minute. Yeah, that's exactly one of the problems I had as well. You have to add this thing here.
Okay.
Oops. You have to add the deriving show and equal. So if you just want to skip through and not type along, you can pull from the repo again. And then it should just work. I mean, it should just fail because the tests fail. How much time do I have in this hour?
Takes still 15 minutes.
2 minutes.
2 minutes.
2 minutes.
All right, then I'm gonna give the break here. If you want to try something out, I suggest you try implementing this instead of just having undefined. see if you can come up with something without writing any tests, and then we can look into how to test it.
What was the dependency? Regarding
Time.
Time.
Yes.
Only time.
Yep.
Only time.
That's a library dependency. I just want to check if is it clear what I'm trying to do, the use case, the hour minute thing. Is that clear? All right, because all the other parts are just little bits and pieces that you need to know about in order to make it happen. They're standard development practices, but you need to know about them. Yes?
Take a look at this. Am I getting like a real test error?
Yeah, that's exactly right.
Okay.
So you're at the right point now. So I can quickly explain this error that you see here. This is the error you're supposed to be getting. And it says that while trying to evaluate this test, I got an exception I wasn't supposed to. This was the exception, this was the call stack, and here was the argument that was used to run the test. All right. In the break, I'm going to use the restroom, so I won't be here for questions. All right, let's do some more testing. So, did anyone try to get an implementation that made the test screen? Yeah, so one person, and he did exactly what I would do. Let me show you what he did.
Huh?
I mean on my screen.
Yeah. I just returned hour minute with hours, 42 minutes 69.
Yeah. Voila, and now the tests pass. Super, our code works.
Yeah, actually.
So what is, this is exactly what I would have done. So just shotgunning until the tests pass. And this shows you exactly that the tests are wrong. Well, not wrong, just not enough. So you would want this to fail for multiple reasons. First of all, it's constant. And second, it returns things that don't make sense. Right? You have a number of hours that's more than the number of hours in a day. You have a number of minutes more than a number of minutes in an hour. And it's a constant. So these are three things we really don't want to happen. So how would we write tests to make sure that these don't happen? The first is you want to make sure that hour minute has the correct validity instance, that is an under approximation of validity. So let's write a custom validity instance that says that the hours must be between 0 and 23. So I'll write validate, that's the function you need to implement, of hour minute. I'm going to use record wildcards to make typing a bit shorter. I'll explain what record wildcards are. So usually you have to write hour minute with or just HM or something, and then you can apply the selector functions. But with record wildcards, which is the second language extension here, now hours and minutes are separate things in scope that are just integers. So you don't need to apply these selector functions. These selector functions in that scope become the integers. Make sense? This is not per se a good thing in general, but it's easier to type, especially now. So what we'd want to say is that, so we return a validation thing. I'm going to show you the documentation so I can explain it as well. So a little detour about how to implement these. If you go to data validity, the documentation, I've tried to document this quite well. This is the type class that we want to be implementing. It's called validity. There's only one thing you need to implement. It's called validate. It goes from your data type to a validation. You don't need to know what's in a validation, but you should know how to construct them. They are a monoid, which is important, so you can put them together, combine them. And then here are the important functions. So there's trivial validation, which just says all of the values are valid as long as they don't crash. And then there's check, which checks a Boolean value, a string that describes the Boolean value, and turns that into a validation. There's the declare, which is just the same thing but flipped. There's annotate, which gives a subpart of the thing you're validating a name and then checks the validity of that recursively. There's delve, which is the same thing but flipped. And then there's decorate if you want to have some more extra decoration. So that just gives another location string. And then there's also invalid if something is trivially invalid with a given reason. And then there's also valid. Make sense? So let's write one. So we will want to concatenate a few invariants. Yes, so first we do, I actually like to use delve instead, but it doesn't really matter. It's just flipped. So this is what the generic instance generates. Just go recursively. But now we want to add something. We want to add declare R's are positive. And declare R's are fewer than 24. Now we have a better validity instance, and now already the test fails, and we get a nice error message saying validate reported this value to be invalid. The value is r_minute, the thing that we return, and the validation failed because there is a violated invariant that the hours are fewer than 24. The input was this value. But we're not done. We want to do something similar for the minutes. So we say declare minutes are positive minutes, and declare minutes are fewer than 60. Now we have a nice custom validity instance. Does this make sense? All right, so let's make sure that the tests pass again. Let's do some work because we made a mistake. Let's fix it. So we'll do, 23 and 59. And hey, now our tests pass again. But it's still wrong. So what else is wrong? This is a constant. So now this is one of the problems we see. So we write a test to make sure that we get a test failure that shows us that the problem that we think is there is actually there. And the one I'd want is to check that this hour_minute is a good representation of the nominal diff time. And the way I would do that is have a reverse function as well. And then I would want to say, I describe that this function is the inverse of hour_minute if you start with a nominal diff time. So then we say inverses on valid hour_minute and to nominal diff time. What's wrong here? All Alright, so looks like I used the wrong name, so let's find it together. Sorry? So in gen validity property, there is a module called functions inverse. And here are some properties that you may want to use. Inverse functions on valid. That's exactly the one I wanted. There we go. Now we get another test error. But I wouldn't just want this way, I'd also want it the other way, and that's when we get into the gen validity problem. Everyone still with me until here? Now I also want the reverse property, that if you start with an hour minute and go through the nominal diff time, you'll get back to where you started. So that's just accomplished by switching these two around, and now we get another time error, another nice type error, saying that you haven't defined how to generate valid hour minutes. This is where the second part comes in. You do that by saying instance gen unchecked hour minute. The implementation is automatically generated. This explains to the compiler how to generate arbitrary values of this thing that don't necessarily satisfy the invariance. And then you also say generate a valid one with gen valid. And everything is auto-generated. And now we have another error here.
Scroll down a little bit.
Where?
In the section cycle.
Oops. There we go. Does this make sense? Do you think that if we were to implement this correctly, then our thing works? So these are rather cheap tests, right? You have the tests specify that the round trip properties in both directions work. So now that means that if the tests pass, the representations should be entirely interchangeable. So let's try to implement some of this. Let's start with the true nominal diff time so that it's no longer something that just crashes. A nominal diff time is just a number of picoseconds, and I'm going to see if I can show you that. Here we have the documentation for nominal diff time. And you can see that you can create a nominal diff time from a number of picoseconds, and if you look at the source code, that's exactly what it is. So how do you make a number of picoseconds? How do you make a number of picoseconds? All right, so I may have to do away with the nominal diff time for ease of use. Let's just do it with an integer, otherwise we'll get into some trouble later. I have to use another. So how would you turn an hour minute into a number of picoseconds? From the silence, I'm assuming some people are stuck. So how would you turn an hour minute thing into an integer that represents the number of picoseconds? Yes?
On the last one, I have to display the error that 2 picoseconds don't take hour minute as a user argument.
Sorry?
The last test
Yes?
is tries to apply hour minute as a first argument. The picosecond. And complaining that such a function doesn't exist.
Oh, I did have to do some renaming. Did you do the renaming as well?
I don't know.
Can you look at lib? Right. The last function on my screen, you don't have it.
Ah, okay.
So given a number of hours and a number of minutes, how do you make
Convert hours to picoseconds and minutes to picoseconds and add them up.
Oh, something happened here. All right. So that would be something like hours times 60 plus minutes, and then do all of this times 60, then you get seconds, and you do another times 1, 2, 3, 4, 5, 6. That's nano picoseconds. Voila. Okay. Well, nothing started succeeding, of course. So how do we turn picoseconds into hour minutes? This bottom implementation should give you a hint. We can say the number of seconds is x div 3, 6, 9, 12. And then the number of minutes is seconds div 60. And I'm going to call this total minutes, and total hours is total minutes divided by 60. And then hours is total hours, minutes is total minutes minus 60 times 60 times hours. I think this is it. Well, it doesn't work, of course. If you start with an hour minute, it works, because in that direction you don't lose any information. But if you start with a number of picoseconds, then it fails. And the test suite actually tells you exactly why. If you put in -1 as a number of picoseconds, then there is no way to represent that. In fact, it will say that's -1 hour. Wait, why does it say that's -1 hour? Did I screw up the implementation? Does this look wrong to anyone? Oh no, okay, so I see what happens. So if you put in -1 as the number of picoseconds, then you get this hour minute, which is wrong, obviously, because we didn't account for negative numbers of picoseconds, right? And if you do the round trip property starting with an integer, so number of picoseconds, and you say, give me the hour minute for 1 picosecond, and then turn it back into a number of picoseconds, then the result will be 0 instead of the 1 picosecond. And now this test will point you exactly to where the problem is. You don't have a way to represent picoseconds in the hour-minute thing. So let's just add that. Then we have to update the validity instance as well, or positive. Picoseconds greater than or equal to 0.
What does delve mean? Do you need to delve picoseconds as well?
Oh, yeah, delve picoseconds.
What does delve mean in this context?
So delve is the flip of annotate, but that doesn't help, of course. It means that we're going to dig deeper into this part of the data type, and we're going to give it a name for nice error reporting. So what this does is it constructs a validation that represents validating the integer to be valid. It just happens to be the case that integers are trivially valid at the moment. They shouldn't be, but there are long and complicated technical discussions about that. So if ever integers become something that aren't trivially valid, then this will be right immediately. What did I do wrong? Oh dear. You can't have integer literals with an E in it. Can I do that? Now it will complain about type defaults, doesn't it? Yeah, that's annoying. Oh no, it doesn't. Good. So what we haven't done here is said picoseconds is total picoseconds minus 10 to the power 12 times seconds. And we don't have seconds either. Good point. All right, that should be better. Thread blocks indefinitely. What did I do wrong? All right, now all my tests are failing. Yeah, you could say it's progress. So let's fix up the 2 picoseconds thing first. Minutes times 60 plus seconds plus picoseconds. Why doesn't that work? Ah. So now you get into trouble with the actual implementation, but that's really not the point of the talk. So at this point, are you confident enough that the test suite will pass if and only if the code is right? No, someone is shaking no very heavily.
It has no sense to have our minutes, seconds, picoseconds, because it's overlaid. If I have the picoseconds, our minutes and seconds are overly determined.
You're already what, sorry?
So if you have the total picoseconds,
Yes.
doesn't make sense. You have to propagate these to our minutes and seconds.
Yes.
You cannot track these two things at the same time because they overlap.
I think I understand what you're saying. The reason we have this separate intermediate data type is to make reporting easier.
Yeah.
And the thing is, this shows you exactly that it's difficult to get the right numbers out, which is why we have this thing in the first place. So the reason why I'm confident that if my tests pass, then the code will work is because what we're trying to do is have an exact representation of of a number of picoseconds in another format. If we now have a test that converts from one representation to the other and back, and those tests pass, then that means there must be a way for this bijection to be real, right? The only thing we haven't tested then is that the bijection is the right one. So if we add one more unit test that checks that a given number of picoseconds is the correct hour-minute object, then we should have the exact implementation pinned down. Does that make sense? Now, it's a nice exercise of intellectual masturbation to get this code to be correct, but that's really not the point. The point I was trying to make here is that you can set up validity, gen validity, and gen unchecked in such a way that you don't have to type much to get started with the actual implementation with complete constant feedback from your test suite. Does that make sense? We only have the validity instance that's quite extensive because of the invariance. We have one line for gen unchecked, one line for gen valid. We have the derived generic part and the language extension. And now you know exactly what to do with the compiler errors that you see when you're trying to use one of these. And then you can start actually doing the work with the implementation instead of messing around with the tests. That's what I was trying to get at. All right? Now there is one more thing I want to show you here, and that's got to do with the other instances. Suppose that's the wrong one. This gen valid instance has a default implementation that says generate something unchecked and then check if it's valid. If it is valid, then return it. Otherwise, try again. This can be rather slow, especially if you have a lot of invariants or not a lot of representations are correct. So we may want to speed this up, right? So let's try to speed this up in a bad way. I could say gen valid is pure hour minute 0000. This is a valid one, right? But this is still wrong. And even worse is if you get this wrong entirely and you do something like this. Now the gen valid instance generates invalid values. And that can cause a whole bunch of troubles. So if you have a custom gen valid instance, you want to make sure that this actually works. And you could write your entire manual test suite to do that, or you can write gen valid spec at hour minute. type applications. Language type applications. So what happens here is that we're manually supplying a type argument to something that has a type argument. And this checks, this generates this little test suite here that says that genValid only generates valid values. And we get a failure here. It says, this is not true. Validate reported this value to be invalid with this violation. So we have some proof that this genValid instance is wrong. If we now fix it, it should be all right. And I can fix it by just deleting the custom implementation. Unfortunately, there is no test that you can write to make sure that all possible values that are valid can be generated. So you'll have to be a bit smart about that. So this checks that the genValid instance at least makes sense. Now, when you look at these hour minutes, you could argue that if you happen to allow for more values, for example, if hours are 60, or that's a bad example. So suppose you have your custom equality instance for this data type, which may be a bad idea, but let's say you do it anyway. Then you still have to make sure that it makes sense. You still have to make sure that equals equals and not equals are correctly implemented in your implementation of the custom instance. In the equality type class, you can override both of these. You can override both equals equals and not equals. And you want to make sure that not equals is the same as not equals. So you can write your entire test suite for that if you'd like. Or you can say xspec at hour minute and this will be generated for you. You can do the same for ordspec. Of course, that only works if the thing is orderable. And voila. Now we have cheap test suites that check everything that you would expect to be true about these orderings. Does that make sense? What I'm trying to show you here is that testing doesn't have to be expensive. You can get the testing out of the way so that you can focus on making sure things are correct with good feedback without doing a lot of manual labor. Does that make sense? All right, how much time do I have left? Otherwise I can dig into someone else's code. Half an hour? All right, I'm going to take a little break and look at the stuff that you have sent me to test and maybe do some live testing of someone else's code. I may do more of this tomorrow, so if you have any more code that you've written recently or that you've written that hasn't been tested much and you want to see what live testing looks like on your code, please send me an email. I'll put my email on the screen again for the next 5-minute break or so while I prepare for this.
Did you push what you have?
Yes, I will push what I have. Bear in mind that the tests do fail. Right, there it is. There we go. While I prepare for the... Yes?
You have something, some command that you run, that whatever you change,
Yeah, I'll write it down as well. I do this constantly. If it's a refactor, then I do stack build file watch. If it's a implementation, then I do stack test file watch. You can do the same thing with benchmarks or specific test suites if you have multiple. So this is one of the most important parts. It has nothing to do with testing per se, but just in general, if you are programming, make sure you set up a feedback loop before you start doing anything. And make sure your feedback loop is short. which is exactly why I hate working on continuous integration, because it takes hours to do one feedback cycle. All right? Cool, I'll prepare for a moment. Holy smokes.
Just one question, because in reality you can have like developer using wrong constant, for example, not 10 to 12 but 10 to 11, and I think those round trip tests will both pass then.
Yeah.
So you probably have to just fix one point, right?
Exactly.
So
You have to add one more unit test.
yeah,
That's right.
But it should be one, right? So
Yeah, one should be enough. One is not enough to pin down the entire implementation, but one is enough to make sure that all the incorrect implementations that would pass the tests are harder to write
yeah,
than the correct
okay.
implementation.
Exactly.
Exactly. Holy smokes. Sir with the hat and the white shirt. Did you write the crypto implementation thing you sent me? Was that you?
I did.
Yes. We should talk about that afterwards. We should talk about it afterwards. It's going to be interesting. I'm not going to use it. I'm not going to use it as the thing to test, but I'd like to talk about it. That's not what I said.
Could you comment the changes? Push it to the repo?
I did.
Ah, you did already.
Yeah. All right, I've got the next part set up. There we go. I just copy-pasted the code, which was rather self-contained, from the email into here. I committed that and pushed it to the repository. So if you want to follow along, now is the time to pull the repository. I pull from the repository. Whoever sent this in, you don't need to identify yourself, but I will need to tell you that you've implicitly given me permission to break your stuff. So the idea here, it looks like, is to transform.
Sorry? You put it
In the same repository. The commit is called live testing. The idea here is to transform between integers in decimal and integers in binary. Let's see if I can figure out what the idea was specifically. So you enter a decimal value, it gets read, and then it gets converted to a binary number and printed. That's the idea, right? So how would we go about testing this thing in the first place? So the first thing I have to tell you is that everything that happens in the main function can only ever be tested by running the main function. So ideally, you'd put everything in the main function somewhere that you can test the individual components of it. Now let's look at what is in there. It tries to read an integer, which exists already. It's just called read. So the first function can be removed entirely and replaced by read maybe from the text.read module. So we'll not test that part. Then decimal to binary, that the function, the second function, is applied to that maybe. Is it that? Yeah, it's a maybe. And then if it wasn't a good integer, then invalid input is printed instead of the binary representation. So actually the only thing we'll be able to test here is the decimal to binary function. Without looking at the implementation, how would you go about testing something like this? The first thing I see is that there are no invariants on the data type. So any integer is valid because it's trivially valid, and any output string will be trivially valid. It can still be a wrong binary decimal string, binary representation of a number, so we can actually try to fix that part as well, but let's not do that for now. So
What about negatives?
Negatives? Why wouldn't negatives be? Oh, well, we can still see if it works for negative numbers, of course. But I want to look into how you would go about testing something like this. If I were to write this myself, I'd probably have some sort of either a new type over string to be able to check if it's actually a valid representation of a decimal number, or something more specific like a list of booleans instead of an actual string. And then have this intermediate representation. Because a list of booleans is always valid, and it's the right binary representation. The string isn't necessarily. So I'd probably split this up. Now, we can see if this thing works for negative numbers, if it works for positive numbers, right? The first thing I'd probably want to look into is that it never crashes. Given that this deals with divisions, that's a valid thing to try to test, because if you deal with divisions, if you ever try to divide by 0 or something, you may get into trouble. So we can try there. We can start there. Just a test that checks if it never crashes. Keep in mind that I hadn't seen this code before. I can just do produces valids on valids. Looks like it never crashes. So no one made any division by 0 problems. Super. Now, let's see if we can make it generate a string that's actually wrong. How would you do that? the output string will only ever contain ones and zeros, right? So we can try to describe that in a property. It produces strings that only ever contain ones and zeros. For all valid integer out of there, des to bin I, and then we say all character is a 0 or character is a 1. You didn't happen, whoever sent this in, you didn't make sure that it was correct, did you? There we go. So what went wrong? Right. So it looks like -1 is represented as minus in the output string. So we may have to change our property a bit. This could be a false positive.
Where do you see the minus there? It it's -1, but the output is...
Oh, good point. Why is there no output? That's strange. So let's add a little unit test to see what happens. Depth to binary of -1 should be -1. Is that right? Yeah, looks like that worked. So I think this thing generates -1, which is not a 1 or a 0. So in order to fix for that, we'd have to say drop while equals minus. So drop all the minuses from the front, and then the rest should all be ones and zeros. Looks to work. It uses signal? Oh yeah, it does. So is anyone confident that if the test passed, then the code is correct? I heard someone say no. Why? Hold on. Who does think that if the test passed, then the code is correct?
Depends on the test, I guess. But
Well, I mean these tests.
We're just checking that there's zeros or ones.
Yeah.
We're
And
not
you're
checking the order.
right. So you're checking that there are zeros and ones. It never crashes, and it deals with -1 correctly. There are still implementations that would pass the test and be wrong. Now the question is the wrong implementation shorter to write than the one that's actually been written?
Yeah.
And I think it is. So that means we need more testing.
so we could return 1, 0.
Sorry?
We could return 1, 0 in string, and that would pass.
That wouldn't pass the last test, but you can just
Yeah.
always return -1.
Exactly. Pattern match.
Yeah. Or no, just always return -1 will have the same result, right?
Yeah.
It never crashes, only produces ones and zeros, and it deals with -1 correctly. And that's shorter than the correct implementation. So what kind of test would you add to make sure that if the tests pass, then the code is correct? Or at least any code that is incorrect and still passes the test is more complicated to write than the correct implementation.
You could make one that actually goes to binary and then comes back.
To binary and back. How would you read them?
But you still can't have that. Oh no.
That's
No, because if you write, if you put in 59 and it returns -1, and that's
So-
how it's going to come back to 59.
So that's a great idea. I don't have a separate function that turns this kind of string back into a number. Is there one? There may be one in the prelude, but I don't know if there which one it is or where it is, so I'm not going to try this. This is a very good idea, and it would I think that would give the test the property that I'm looking for, but there is a cheaper way to do it.
Add 1 unit test.
If you have 1 unit test, then you can just pattern match on 2 of them. If you had 3 unit tests, then you can pattern match on 3 of them. If you had 4 unit tests, then you can pattern match on 4 of them, but then the implementation is longer than this one.
Yeah.
So One thing you can do is write another. So I'd probably write something like, if the input is positive, then the output is positive, and then write another unit test, and that should be it. Does that make sense? No one complaining about that?
It makes sense, but it still doesn't make it like 100%.
No, absolutely. But the thing is, depending on how much safety you need, you require, you get to justify spending more time on this. And I'm specifically looking for cheaper ways to test as opposed to more guaranteed ways to get something to be correct. So if it's good enough, assuming that programmers are lazy and don't use undefined, to write 3 more property tests, or 1 more property test, or 3 more unit tests, or whatever, then I'd prefer to teach you that now than to teach you a way to guarantee that this is correct. You see what I mean? All right. How much time do I have left?
Is it 15 minutes?
15 minutes?
I guess.
All right. So let's just write these and then leave it at that for today. So let's write the test that positive numbers don't start with a minus, right? It produces numbers that don't, positive numbers for positive integers. So actually this tests even more, doesn't it? Oh, I still need to make sure that the input is positive. Right, so we do for all gen valid such that, oh, actually absolute value on gen valid. There we go. So this may be a bit complicated and not something you've initially thought of. But the way this test is structured is you say that for all values that are first randomly generated and then the absolute value is applied to it, which makes them positive. For all of those numbers, if you look at the string that des2bin outputs, then if it's empty, that shouldn't happen, so false. If it starts with a minus, that shouldn't happen because the number is positive, so false, and otherwise it's true. So this just checks that the output is not empty and it produces positive numbers. All right? And now, what other test did we say we were going to write? A single other unit test, right? What kind of unit test would you like? Someone said 59. So 32, 64, that's 48. 56. I think that should be it. There we go. All right, so it deals with 59 correctly as well, produces positive numbers. And now, instead of these last two, I'd probably have written the round trip test that you mentioned. But this test suite gives me enough confidence that the implementation is correct, while being cheaper than proving that it's true, or nailing down the implementation with properties entirely. Does that make sense? All right, then let's leave it at this for now. Even if these seem very easy tests to write, it is worth going through the exercise, especially if you don't have a lot of Haskell experience, to do this once, even if it's something simple like testing if this thing works. All right? So So feel free to practice this as well. If this was boring, tomorrow we'll go into more complicated details as well. Thank you.